Have you ever wanted to use the Hype app to make motion graphics for whiteboard explainer videos? Simulated handwriting and animated drawings can certainly be made with Hype. But, making an entire video could be a lot of work if you have to manually coordinate the image of a drawing tool with these motion graphics. So, you might be wondering, how can I automate the connection between the image of a whiteboard marker and the underlying motion graphics to give the illusion of hand drawing? Fortunately, Hype elements can be manipulated with JavaScript. With some relatively simple code, you can programmatically enable a drawing tool to follow an existing path in a coordinated fashion. Making animated drawings and handwriting in this way is significantly quicker, but also much easier to revise and update later. I've made this video to show you how to implement this idea and explain how you might use it to streamline the process of making graphics for whiteboard explainer videos. Creating the illusion of a hand drawing is a matter of coordinating the movement of a drawing tool with a corresponding motion path. Here is what this kind of coordination looks like. Coordinated movement like this can be achieved manually by copying the path and timing data from a drawing and then pasting it into the corresponding motion path for the drawing tool. In Hype, this can be done without any coding and is attractive to many people for this reason. I'll provide a link in the description below to another video that shows how to use this manual method. However, it would be helpful if this coordination could be done automatically, especially when the size and complexity of each video scene are large. Or, when there are many scenes required to make a larger video. The goal of this video is to demonstrate how one small piece of JavaScript code, running in the background, can automatically coordinate the animation of a motion graphic and a whiteboard marker. If coding isn't your thing, don't worry. You don't actually need to know JavaScript to make this work. In fact, I'll show you exactly what code is required, where to put it, and how to configure your Hype elements to make this work. I'll demonstrate this in 3 simple steps using the example shown here, but the same steps can easily be applied to your particular use case. So, let's get to it. Before we get to the first step of adding JavaScript code to coordinate this animation, it is important to understand how the example project is set up. There are 4 main elements here. A video frame shape, some text elements, and some invisible connector paths that join these shapes together. Staged off canvas, you can also see a hand holding a whiteboard marker. If you run this animation now from within Hype, you can see that the shapes and characters animate in sequence as you would expect. But nothing happens with the whiteboard marker. This result is different from the manual method I mentioned earlier, where there was a duplicate set of motion paths that dictated this marker's movement. These motion paths would have shown up if you had run the main timeline in Hype. It is important to recognize that we're omitting this duplicate set of motion paths, and that is the main way we speed up our construction and editing workflows. However, even after adding the JavaScript code, you will only ever see the full animation if you preview it in a browser. That is just how JavaScript in Hype works. So, how do we add the JavaScript code that enables this whiteboard marker to track the motion of these different shape paths? The magic piece of JavaScript code that enables this coordinated movement is called a mutation observer. This is a JavaScript function that is recognized by all modern browsers, which allows you to monitor an HTML element for changes in its appearance or behavior. The changes in our case are the animation of a motion graphic. When this change occurs, the mutation observer triggers another piece of code that does something in response to this change. For us, that means to move the whiteboard marker to a new position that matches the end of the line being drawn. Using mutation observers inside of Hype from scratch could be quite involved, but fortunately Max Siebel, a longtime Hype champion and forum contributor, has authored a Hype wrapper for this function that does the hard work for you. To use this piece of code, all you have to do is download it and then import it into Hype. There are several ways you could do this. The easiest way for our purposes is to go to the CDN version of the file at this link and then save the resulting file to your machine. Make sure that you save it as a JavaScript file with a .js extension. Don't let your browser add a different file extension by default. I'll include this URL as a link in the description below, so you don't need to copy it down. Then simply import this file into Hype directly through the resources pane. Be sure that you check this little box at the bottom indicating this file needs to be added to the head of your document, otherwise, the code won't be included at runtime, and the animation will fail. Once this is done, it is ready to use, and we can go on to the next step. I've also included a link in the description to Max Siebel's GitHub page so you can see his many other Hype projects. If you are interested in other ways to extend Hype with JavaScript, these projects are certainly worth a look. The second step in this process is to attach classes to Hype elements whose movement you want to coordinate. In this example project, we'll need two specific classes, one for the whiteboard marker and one for all the lines being drawn. By way of example, let me show you how to assign a class named Line to all the paths that make up the video frame. In this image of the Hype user interface, you can see how I've already selected the elements in the video frame, here. And I also have the identity pane open on this side. Zooming in on the identity panel, you can see a section for assigning class names, here. Next, I'll simply enter the word line into this section. After this, you would need to go on and assign this line class to all the other lines that make up the character shapes. As well, you would also want to assign a separate class to the hand and whiteboard marker. With that, all the necessary elements have a class designation and are ready to be animated, so let's go and do that. The final step in this process is to add some custom JavaScript to Hype that links to Mutation Observer library that we imported earlier, to the elements we just added class designations to. Let's call this function line observer, because that is what it does. We want this code to run continuously in the background, so it is best that we add it during the time the scene first loads. To do that, you need to go to the scene pane, here, and add a new function under the onScene load. I've already done that, so let's briefly examine the code so you can understand what is going on here. You can find this function by clicking on the interface tab with the same name. If you are new to JavaScript, this syntax mightn't make much sense. However, the code will work even if you just copy it directly, without ever understanding how it works. I'll explain it briefly, just in case you want to customize it, or use it in a slightly different context at some point in the future. So, let's navigate through each line of code. In the first part here, we are getting references to the classes we just assigned to each of the lines and the drawing hand. Next, we need to calculate the offset between the drawing hand's position relative to the top left of its element. This is needed because unless the marker tip resides at exactly the top leftmost point of the element, you will need to calculate the difference between it and the line you are tracking. This is necessary because the coordinate space you are working in has its 0,0 point at the top left of any space or element. This offset can be minimized by trimming the image of your whiteboard marker to make its drawing tip as close to the top left as possible. The next section of code, here, is what actually moves the hand and marker each time there is a line that changes. This is done in two steps. Firstly, that offset correction calculated earlier is applied. Then the code tracks changes in any line from our line class, and then repositions the drawing tool to match that position. And that's it. If you preview this project in a browser now, you will get the full animation shown at the start. I hope you enjoyed this short video demonstrating how to programmatically coordinate the image of a drawing tool with motion graphics in Hype. In addition to producing video graphics more efficiently, this approach definitely lessens the work involved in making small changes or revisions to your video scenes. However, this video has barely scratched the surface of what is possible. In particular, there are many more code-based ways to animate hand drawing in Hype, together with other workflow improvements. Are you interested to see other videos describing how Hype can be used as a tool for making whiteboard explainer videos? Well, I've prepared a package containing a full set of demo videos, Hype project files, and resource libraries together with some documentation describing ways to optimize your motion graphic production workflow. If you are interested to learn more about this package, contact me at alteredmindware@gmail.com for more information.